Okay, yesterday we were talking about cylindrical shells. We barely got into it. The long idea of it was, first of all, for a figure that we're looking at, guys, do we still have an area, a region that we're looking at? Okay. Is that region still being rotated?
Yes.
However, if this is a disc or washer, what will we make our thickness? dx, right? We will be slicing perpendicular and we'll be taking out those circular discs or those circular washers with a depth of dx. However, what do you notice about what they have labeled right here?
Delta Y.
They have cut parallel. They have drawn parallel to the axis of revolution. And the reason is because they're taking this representative piece. We will zoom in just 1 second. They're taking this representative piece and they're rotating this piece around the axis. And as this rectangle with a thickness of dy, as it rotates, what does it form? A shell, a cylindrical shell. Let me go ahead and try to show you an illustration of this. I'm going to go ahead and restart it if I need to. Okay. We start with an area of a region. That area of a region, this one, guys, is being rotated around what? The y-axis. Okay, so that area, when it's rotated, can generate the volume of the surface that's shown. Now, when we're trying to partition, you guys can barely see it, but they're partitioning. Now, they're partitioning parallel to the axis. They take one representative rectangle, and as they rotate it, they'll get one cylindrical shell piece of the solid. However, that's not the entire solid, right?
No.
Okay, that's only one part of the solid. And so if they start on the inside, and if they do that for every single piece, I'm only showing you half of it just to try to help you visualize, is it an approximation of the entire thing?
Yes.
Yes. And if it was to keep on coming around, right? They're finishing it, finishing it, finishing it, finishing it. Is it perfect? No, but that's the whole point. It's an approximation. What does the integral do to each of those? Makes them infinitesimally thin, so that way it will smoothly generate the entire figure as they get infinitesimally thin. So it was fragmented, but so were Riemann zones until we put them in an integral and have them accumulate throughout the region infinitesimally thin. Another way of visualizing it in a way or in a sense is if we were doing another region, rotating this region around this y-axis, we would cut perpendicular for both the discs and the washers. You guys see here, they're showing the discs and the washers, right?
Yep.
For the discs and the washers, we cut perpendicular. So these slices are being cut right to left, and then we accumulate. The discs accumulate, but the washers are needed when we have not a region not flush to the axis. So that's how discs and washers work, cutting perpendicular. But shells, once again, cut parallel for the representative rectangle. It would be a thickness of dx going around the y-axis, and then we would go ahead and be rotating that region all the way around. You can think of it as, they were trying to show different illustrations, as an onion, kind of more like cylindrical shells. Not just like, we wouldn't just do the circular, I mean you can do the circular, but you can also do the shells. Also matryoshkas, you can think of cylindrical shells as accumulating throughout. Some of you guys have wondered since last year, it's a little bit harder to see. Some of you guys were wondering since last year what this was demonstrating. What is this demonstrating? Pair of shells. Yeah, the shell method. Because in order to get this region, could I have, if this was solid, could I have gone this way and could I have sliced it and had washers? Yeah, I could have sliced it and had washers, but what did they do instead? They had shells. And so each of these, now this is like, I don't actually like this, to be totally honest. I don't like this figure as much as I would if it was segmented, because how many pieces are there? Finite. So should this be smooth? Yeah. What should it be? Segmented, if it was properly done. The tops should be like this and flat across. So I don't totally like this illustration, but it is trying to give you the idea. But if I build the shells, am I going to get a three-dimensional figure? Yeah. If I can make them infinitesimally thin, then it would be nice and pretty and rounded like this one is. But they went ahead and cheated, and so these aren't perfect shells. Is that a cylinder? No, it's not a cylinder. If that was on the other side, yes, it would be a cylindrical shell. Okay, they tried. So then coming back, I know, it's the idea. The hard part we have to figure out is, first of all, well, hold on. How do we get the volume of a shell anyway?
Well, you take the volume and you subtract that.
No, I was thinking of taking like a cylindrical
Volume,
volume pi r squared h, and then he's trying to like pull something out. No.
I mean, if you have the bigger radius and the smaller radius, you have to.
Another way of thinking about it is, kiddos, for volume by discs and washers, don't we take the area, the cross-sectional area, and give it depth? What would be the surface area of a cylinder, and then we give it depth? Pause one more time. For discs and washers, don't we use pi r squared?
Yeah.
Which is the area. And then we multiply by dx or dy, which gives it depth, right? So we're going to do the exact same thing with the cylinder, but with the cylinder we need surface area and giving it depth. So, question, how do you get surface area? Hey, wouldn't you just cut the can label and unfold it, and what shape would it give you? Exactly. So that rectangle, wouldn't it have a length of 2 pi r if you cut the circle and unwind it? It had a length of circumference, and what would the height be?
Times h.
So the surface area of a cylinder is equal to 2 pi r h. Hey, what's in all your formulas? 2 pi r h, 2 pi r h, and then times a thickness. So if you give it a thickness, then all of a sudden, don't you have a shell?
Because you don't have to subtract anything.
Nope. That was Noah's idea, which wasn't a bad one, but it's easier to think surface area, which we did with discs and washers. We did area and then depth. Same thing here, surface area with the depth. And then we get our cylindrical shell. So that's where the 2 pi r h is coming. 2 pi r h is the surface area, and our differential gives us the depth. Now, the difference, another difference that we need to think about is horizontal versus vertical axes of revolution and whether it's dx or dy. So let's look at this picture in a new way maybe that you might not have been able to before. If I am rotating around the horizontal axis, parashell method, just kidding, it's a shell method, but parashell, you guys get what I'm doing, right?
Yeah.
You're going parallel with your representative rectangle. You're thinking right to left, and that rotates around. So our shell is going to be coming around. Our thickness is going to be dy, right? Our radius is going to be from the axis to the outermost. Ooh, that's the same. From the axis to the outermost, that's going to be our radius, because then as I rotate around, so the radius is still top minus bottom. Oh, that's weird. The radius is still top minus bottom, but it needs to be in terms of what? Backwards discs and washers. Top and bottom for discs and washers are dx, everything in terms of x. The radius is going to be top minus bottom, and how am I going to get my height? Right minus left. In a way, it's backwards. Huh?
So radius is top minus bottom.
In this one, radius will be the outermost minus the axis. So top minus bottom. Which, if it hasn't moved anywhere, isn't the radius, like for this one, isn't it just going to be the y value because it's y minus 0? Right? So it could just be something as simple as y minus 0. But we are going to have to think top minus bottom, because if we're rotating around y equals -1, well now it's y plus 1. Y minus -1. What's the height of my cylinder going to be?
A fixed number.
The function minus the fixed number or the bound. Unless the function is naturally bounded by an intersection point. That might be possible also. And then in this one, when I'm rotating around the vertical axis, I'm going parallel, cutting parallel. That is my thickness, dx. That's rotating around. My r of x is going to equal, well, this one hasn't shifted anywhere. So in this one, my r of x is going to equal x minus 0. X minus 0. And then my height is going to be top minus bottom. So we're dealing with right minus lefts and top minus bottoms.
It can be
For high school?
Yeah.
Okay.
Is it for you?
For
Carolyn again?
Oh, middle school gave their own, the same pentagrams?
No, middle school and high school does separately. High school is their first period.
They
and
use
middle
some of our
school.
tags.
Oh. So I got this one already, so now I got another one from the middle schoolers.
Oh, let's go.
Okay. And then Sarah Hakeem got this one this morning, but she got it.
Yeah.
Okay. Teacher. Alright. They're cute, they're trying. Okay, coming back. So in this one, R would be, now, basically we should get to examples. So let's go ahead and go down really quickly. The parashell and the perpendicular.
Is that looking
Parashell and perpendicular. What am I trying to say? Perpendicular. Yeah. The thickness, which is representative of the differential. The thickness, which is relating to or corresponding to the differential, hence dx or dy. The thickness is perpendicular to the axis of revolution, right? And then for the parashell method, if I'm doing the shell method, the thickness, which relates to the differential, which of course determines whether I'm in terms of x or in terms of y. You guys are tracking with that, right? If it's dx, I better be in terms of x. If it's dy, I better be in terms of y. It's going to be parallel to the axis of revolution. Okay? Which, let me finish the thought. No. So if I have a horizontal axis of revolution, that would be a y equals, I'm going to have dy. And if?
You're getting a bunch of kids ups today.
Is this actually? BC, do you want cookies? It was left over from our board.
You bribed the judges with cookies and hot chocolate?
Oh, yeah.
We also have a cute little bagel.
Don't be
You bribed me with a dog?
That is really, that's not mine.
Yeah, that's really pretty.
Oh, Katrina, give me one of those orange blue pepper ones? Those things are fucking bomb.
Let's drink it.
That's in yours, okay? I'll take one more gingerbread man. Alright, kiddos. Here we go. I'm gonna go back to that.
Oh yeah, can we take our time? Oh wait, I didn't get some written down. Oh wait.
I think all the fun stuff has been taken down by now, probably.
Can I see that last page for like a split second? I just need to see what word one. Thickness differential. Thank you.
It'll dissolve together. Your stomach's decision dissolves out.
Thank you, Ted. She was just really stressed and I felt bad, so I was like, if someone could just be out there.
Yeah. Everyone was
What were they doing?
just like, they're like crowding everything.
Oh, so then like no one could see it?
Oh, so everything's set for Friday.
Alright, Cabby, we're good? Alright, kiddos. Here we go, examples. Examples. We have the exact same volume being found two different ways. My question to you is, which one is washers and which one is discs?
So, first one is water.
Oh, not discs. What is it? Shells.
Shells.
Do you see how one is dy and one is dx? Okay. For the dy one, we would see that with the thickness of the disc up here. And if I was to get a little yellow highlighter, I would go right minus left. Wait, why am I showing you two different ways of solving?
Versatility.
You might not understand exactly what I'm saying, so I'll come back to it in a second. I have only if I can make it straight. have only one line for the first one, but I have 3 lines for the second one. Can anybody help me out as to why? For the first figure, Corey, if I was to do this in terms of y, if I was to go ahead and need to solve with discs and washers, I would need to do discs from 0 to 1 and washers from 1 to 2. True? Okay. Yeah, but stop with the head bobbing because I'm distracted. Thanks. So, of the first figure, if I was doing discs and washers, I would need to do discs from 0 to 1, and I would need to do washers from 1 to 2. Right? And then in the second figure, I would need to do, well, hold on. I could do shells the exact same way the entire way through. John, what's your question?
For shells, would you, one of them would be the total volume, or would you have to do it multiple times?
Both of these will find you the entire volume because both of them will accumulate. Let's set it up and see if it makes sense. So, do you guys at least have the parameters written down? We have an x squared, been shifted up 1, being cut at 1 and at 0 and at, well, ultimately the intersection point, which is 2. We okay? All right, let me go ahead and scroll down. Okay. Okay, if I was to set up with discs and washers. Question. When I go to set up my integral expression, I would have pi times. From 0 to 1, what would I go ahead and put in? I have dy, those are my circular discs.
1 minus.
Good, 1 minus 0. From 1 to 2, what would I have?
Square root of x. No, square root of y.
1 minus 1 minus 0.
Minus. Oh,
What was my function?
X squared plus 1 plus 1.
So x is equal to the square root of, double check me, y minus 1?
Yeah.
It's the positive stuff on the right side?
Yeah.
So it has the square root of y minus 1 minus 1. Nope. You guys agree? Okay, pause. That all makes sense, right? Wait. Why couldn't I just do washers for the whole thing? Whatever, there's no gap here. No big deal. What would happen if I tried to do square root of y minus 1 from the interval 0 to 1? It doesn't exist. There aren't any y's. This function doesn't even go down that low. So I had to add this extra piece. I had to add the cylinder on the bottom. Now, this side, how fun does this look to solve?
so fun.
It's discs and washers because we need discs because it was solid to there. We needed washers after that. Everything in terms of y because we have a thickness of dy perpendicular to the axis of revolution. Over here, it's going to be harder to visualize. We're not as used to it. But over here, we could still visualize without even doing the whole thickness thing. The thickness is just going to be that representative parallel, which will be dx. Parallel to the axis of revolution. And then I have a cylinder. As I rotate this representative rectangle, and Katrina, we had this illustration beginning of class in the video that'll really help.
Okay.
I need to think about radius, r, and height, h. Right? Okay. So as I go to plug in, v is equal to 2 pi. What are my x bounds? 0 to 1. Good. R is going to be right minus left, but think, isn't right just the x value of a point? Right is going to be the x value, left is going to be the 0, because on this one, x is x, and on this one, x is 0. That's a horrible way of writing it. But at a certain point, any of these representative points on here, the x, this x is the x that goes with whatever the value is, and so this x would be 0. So you say, okay, the horizontal measurement is x minus 0, which is just x. However, I can't just put y because it's not in terms of y. I could put x, it was in terms of x, but I can't put y. So, okay, question, what is my y minus 0 that I'm going to use? Well, what was my function? Y equals x squared plus 1, and technically minus 0. Who looks easier to solve? Discs and washers or shells? Oh yeah. But what's harder to set up? Shells. Now pause, one more time. What was my radius in this one? X. Oh, sweet, okay. Well, and then the axis was 0, so x minus 0, cool. Plug it in, it's dx, I just plugged in x. What was my height? Y minus 0. Oh, I can't just plug in y, it's dx, so I have to go ahead and go get the function for y minus 0 and plug it in. Done.
Will r always be x? Like, for the dx?
When the cylinder is oriented this direction, yes, but it might be x minus a constant if the axis of revolution is somewhere else, or a constant minus x and it's oriented the other. And if the cylinder is the other direction, r will always be y, or y minus a constant, or a constant minus 1.
Okay.
Okay, if someone wants to be really amazing and plug it in their calculator and show us that they're both equal, or we can just say, you know what, we believe Miss D will go on.
We believe you.
Cool, go team. Ready, set, do it with shells, go.
For shells, is the axis like the opposite of the washers? The differential and the opposite on the opposite. Because of this. Take the surface, I take this. We do the surface area, pi squared times thickness. For cylindrical shells, first of all, we're going to parallel. So it's going to be the other. So like this. When we slice it, that slice comes around, and as it comes around, the surface area of the cylinder we saw was 2 pi r h. So we did 2 pi r h times thickness, and then we get that shell. You guys paralleling? You paralleling? If it helps. If it helps, are you drawing a cylinder? Could you give it thickness if you're super artistic and can do it fast? Sure, I'm not. What's the thickness? Why? Because the thickness of this parallel piece, if I were to give it thickness, would be horizontal. Or think you're going around x equals 0. For discs and washers, if we were going around an x equals line, it would always be dy. But for shells, if we're going around an x equals, it's always dx. Some of you might just memorize it. The idea helps me because I'm a visual person, but it might not help you as much. My R, have you guys already figured out who he is?
Yes.
R is just x minus 0.
So it would be like x minus plus 1 if you were
If you were rotating around x equals negative 1, it'd be the x, which starts from 0 plus 1. Or minus a negative 1.
Why is it x?
Because x is always the horizontal measure from the y-axis. So since this is still going around just the y-axis, the horizontal measure to any point will always be its x value. The vertical measure will always be its y value. So since this is going up, this could be y, but I need dx, so I need to go ahead and say, oh, well, that's going to be the y's equation. Yeah, which will be, no, in terms of x. So technically we'll get v is equal to 2 pi. What do you guys get as your x's?
2 to 4.
Mm-hmm. Why wasn't it 0 before?
Because it's the
nature of the graph. I gave you the picture. Could you have done it? It's a square root function shifted 2 to the right. When they told me function y equals 0, x equals 4, it bounded it so that, yes, the x bounds have to be 2 to 4. Lucy, go ahead. Plug in my r is equal to x and come right back. H, I'm going to plug in. It's just my square root of x minus 2. And have my dx. Solve with what?
Integration on crack, you said?
Yeah.
Right? You would be that guy, he would be solve for x and plug in, go, go, go.
Yeah. So why would you put in y equals 0 if it's not even bound by it, and they already know?
It is bound by. It's not bound by x equals 0.
I'm so sorry.
No, that's okay. I was thinking some people would think this was 0 to 4. So yeah, they were bounding here, not there. If they were bounding there, it'd be a totally different picture. Right.
So for the square root of x minus 2 minus 0, what do you subtract from?
The thing you
The bottom. So think of this as my y equals square root of, right? And think of this line. So I'm doing the top of it with the bottom of it, and then with my radius, I'm technically doing the right of it, which would be the x, minus the left of it, which would be 0. I'll get a weird example so you can see it in a different way. Hold on, pause. Any other questions about how I plugged in? Oh, it's still an axis one. Can we go find a non-axis one? Like a non-easy add an axis one, is that okay? There we go. Can we go there?
Isn't that it?
Just
Cross it out and say it at,
Oh yeah, we can do that. Can you change this one?
yeah.
Okay, I'll change this one. Let's say about
Just say that's.
y equals -2. There we go. Let's just change it. Good call. Make it a little bit higher again.
Good job.
Oh, I erased them. Sorry, I erased the bounds. I erased the bounds. I apologize. I think I cleared the whole page of writing and then I erased half my problem. There you go. The region bounded by 1 over x, y equals 0, x equals 1, and x equals 4. All I've done is parallel, right? All I've done is parallel. How many of you guys are actually thinking of drawing the cylinder? Just one little cylinder. That's it. I think I would always draw it.
Thanks so much.
The R and the H.
Yeah, but like, when you like went into like, like, did you just start like halfway through like halfway through?
When I did this one?
When you like started to draw the cylinder.
Oh.
Like if you were.
I just take this and I go to the other side. So then I just connect it.
Wouldn't you just do 0 to 1?
Does that make sense?
Yeah.
I just connect it.
Yeah. 1 and 4. Yeah, I'm going from the bottom.
And then for like the
We'll
last
grab
one,
the
just
top.
just
0 to 1.
I went parallel,
Oh, yeah.
and then I went the same distance on the other side. So I did here's my axis. I went parallel, and then I just said, okay, this distance over here, I'm going to
How was that different?
Alright, pause. Some of you said, actually all of you but Lucy and I say that you're not going to draw the cylinders. Okay, how are you going to think about R and H? R, I can see it on mine. He's right there. How are you going to think about it? H, I can see it on mine. He's right here. Have a way of thinking about it. I'm going to go ahead and plug in. What's my formula for shell? Do you guys have it memorized yet?
2 pi.
Pause! You can't do this until you figure out the thickness. How did I draw that representative rectangle? Parallel. What is its thickness going to be? D1. You can memorize it from your endeavor card. where you can visualize it and understand it. So I need y bounds. What are my y bounds?
0 to 1.
0, because y equals 0 is my bottom. And I need to figure out what this y is, which is when x equals 1. We'll plug it in, plug it in. 0 to 1. My r has something to do with y, because it's a height. Has something to do with y, but up here, when I'm drawing, oh, I should have drawn up by my curve. Lame sauce. Hold on. I just was having too much fun with the parallel and wasn't making it accurate. I need to draw a parallel with my function. The whole point is my function is determining. There we go.
You can't click on your
No.
I'm sorry. Okay. You can just like. Okay. Pause. There's still my R. Now my H is only so 1. Okay. My R is my Y value, except, is that all the R is? No. So what do I have to do?
Y plus 2.
Y minus a -2 or Y plus 2 is my R of Y. Because it's the Y value, how high from the axis minus the -2. R times H. My H is going to be the function, but I need it in terms of Y, so that would be x equals 1 over Y, right? My function, but my function minus what? Minus 1.
Wait, why is it like?
Because the gap between 0 and 1.
Because when you go this way, that's x equals 1, and this is x equals 1 over y. So that's this, and then that's that. Now, there is a slight dilemma with this one. Does anybody know what the slight dilemma is?
Is it the solid flush part?
No, not 1 minus, because 1 over y is horizontally to the right.
It's because there's a one. It's not gonna
Have we not taken into account the taking off the No, but
Oh, no, we have. We've taken that into account. Because we're starting at y equals 0, going to y equals 1. Pause, guys, this is wrong. It's not right. What's wrong? Yuki, what do you think?
The bottom part of it, but it shouldn't be, the height shouldn't be like that, because it should be 4 minus 1.
If you're thinking about the shells accumulating, this is going to have a shell, right? Good. This is going to have a shell. This is going to have a shell. It's going to have a shell. It's going to have a shell. It's going to have a shell. All the way up until, uh-oh. When's my function stop? How is it going to get from 1/4 to 0 and get all of these if it's not hitting the function anymore? Can shells sometimes not be the best method also? Remember how we had to add because the behavior of the function changed for the disks and the washers? We're going to have to do the exact same thing for shells if we're doing it to a region where the function defines part of it, but not all of it. Where the function defines part of it, but not all of it. So technically, as we go towards or between 0 and 1/4, if we were to use shells, we couldn't use as our height, we couldn't use the function anymore, because the function's not determining anything. We could still use our y plus 2 as our radius, but our height would just be 4 minus 1. Our height would just be 3. So the weird thing is, if you are using a function to define, you have to be able to follow the movement. Now guys, technically I probably would have done washers on this one because of how the shape was oriented. I did make you do shells. And maybe that's why I had it. No, even if it had been around 0, that wouldn't have made a difference. We still would have had to split it up because you still would have had your shaved off edge. But the function doesn't continue defining. Shells move differently. They don't move this way through a figure. They move this way. The function got me here. I had to keep going the rest of the way. Okay, we've done easy, we've done hard. I need you guys to get over the weekend into this section 8.3. Wait, 8.3! Isn't it like discs and washers? Sorry. And shells. Bye.
Why couldn't you do chat
We had a little hat on and a little sweater on earlier. Oh my god! He's like a half man. Yeah. Oh my
Was this a fun He was the reindeer.
I got a picture with them. You said you could pop her.
Alright,